Hi folks, and welcome back to Math with Captain Rod here, making this video here to be part one of a note series here on graphing rational functions using asymptotes, or using the asymptotic behavior of the functions. So we're going to sketch a graph of this function here. Nice quick example I've made up here to take a look at. And the idea here is we want to use both vertical and horizontal asymptotes to help us sketch this graph. So vertical asymptotes show up where your bottom is 0 here. So when x approaches 2, this function is going to get bigger and bigger and bigger, either in a positive or a negative sense, kind of depending on the value of x. You notice that if x approaches 2 from the left, like numbers like 1.9, 1.99, 1.999, the bottom will be positive, the top will be positive. So what happens is, if I write it out here, oops. Okay, so what we would say here mathematically here is that as x approaches 2 from the left, these would be numbers like 1.9, 1.99, etc. Then the function is going to go to plus infinity, right? It's going to get infinitely large. Try it with a calculator. Put 1 over, 2 minus 1.999. You're going to get 1,000 out of it or so. If you put in 1 minus, or 1 over 2 minus 1.99999, you're going to get a very, very, very large number. All right, as x approaches 2 from the right, this thing still goes to 0, which makes the function get really, really, really big. But if we approach from the right, 2 minus something like 2.1 or 2.01 is a negative number. So what happens is the function ends up going to minus infinity. So I'll just write that out. The function approaches or goes to minus infinity here. So what we're going to do, I'm going to go ahead and do this in red. I'm going to graph our vertical asymptote first. We know that this thing has a vertical at x equals 2. I'm just going to put a line there. All right, there's our vertical asymptote. And again, this is not really part of the graph. It's just a graphing aid. We know that when the function approaches this from the left, it's going to do something like this. And when it approaches from the right, it's going to do something like this. All right. Next, let's talk horizontal asymptotes. So when you're talking horizontal asymptotes, what we're wondering is, what does the function do when x gets really large, or we'll say goes to infinity, when it gets very, very big? Now, if you take your calculator, it's really easy to show, if you put in like 100 or 1,000 or 1,000,000, you're going to get something approximately 0 out of this. Imagine putting in, say, 1,000. 1 over negative 998 is a really, 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 really tiny number. Anytime the power in x is bigger on the bottom than the top, then the function will be driven to 0. Right? This function is going to go to 0. So y equals 0 is our horizontal asymptote. I'm going to go ahead and let's do that one in green. We'll use that. I like green for horizontal asymptotes. So, and y equals 0 will be your horizontal asymptote anytime the power in the bottom is higher than the top. So anything that's a number over x, a number over x squared, maybe a 3x over 5x to the 5th in the bottom or something like that. Anytime the bottom is a higher power than the top, y equals 0 will be a horizontal asymptote. All right, let's start plotting some points here. So now what we're going to do is we're just going to plot a handful of points. We don't really need that many here. Let's just look at one over to the left here. Maybe, I don't know, -5, just to pick one. And if we put -5 in, our function is going to be 1 over 2 minus a minus 5. So 2 plus 5, which is 1 over 7. And when I graph, 1 over 7 is just right above the axis there, but we get 0.142. And let's take a look at, maybe a point here, like maybe -1. Okay, we're going to have 1 over 2 minus a minus 1. That's 2 plus 1, so that's 1 over 3. That's 0.33. Okay, let's put in maybe 0. Well, that would be 1 over 2. That's 0.5. Let's just plot a couple of these points now. Let's see, 0.5 is like here. Negative 1.33 is like here. Boy, it approaches the asymptote really fast is what's happening here. Negative 5.142 is like, let's see, 1, 2, 3, 4, 5.142, barely above the line here. All right, and let's do one more point. Like, look at 1 here. If we put 1 in, we get 1 over 2 minus 1. That's 1 over 1, which is 1. And what will happen here is if we put in 0.5, we'll get a bigger number. If we put in, I'm sorry, 0.5, 1.5, if we put like 1.9, we'll get an even bigger number. 1.99, we'll get an even bigger number. So this thing, what it has to do here is it approaches the asymptote like this. Boom. Let's kind of investigate what's happening over here. So if we put in 1, 2, let's put in negative, I'm sorry, not negative 3, plus 3. Then our function is going to be 1 over 2 minus 3. That's 1 over minus 1, which is negative 1. Oh, forgot to write that 1 down from earlier. Okay, so 1, 2, 3, minus 1. Now here's where this stuff's really cool. Watch this. We know that if we approach x equals 3 from the right, remember that the function, or I'm sorry, did I say 3? 2. As we approach 2 from the right, the function's heading to minus infinity. You can check that. Just put in like 2.01. You're going to get a big negative number. This thing's going to be straight down. We know that it has to approach this asymptote in this direction. There's a sketch of our graph. Now, this graph was sketched using 1, 2, 3, 4, 5, 6 or so points here. As we do a couple more, I'll probably try it with even fewer points. Once you have the asymptotes, these things become pretty easy to graph. I'm going to move along to the next example here. All right, here we are. We're going to take a look at 3x plus 5. So first, let's talk about vertical asymptotes. This function goes undefined at x equals negative 5. In fact, I'll write the domain over here. The domain of this function is all real numbers except x cannot equal 5. I'm sorry, negative 5. That's the value that would give us a 0 here. So we know we're going to have a vertical asymptote at negative 5. I'm going to go ahead and 1, 2, 3, 4, 5. I like these vertical asymptotes in red. Okay. All right, let's talk horizontal asymptotes here. All right, so horizontal asymptotes are what does the function do when x is large? Okay, so if x is large, or x is really big, then our function is approximately equal to 3x over x, which is equal to 3. Now the reason we can do this is because if x is really big, x plus 5 is approximately just x, just like 1,000 plus 5 is just 1,005. There's almost no difference between them. So that's how you find a horizontal asymptote, believe it or not. You just, I'll do more examples of this, but you just approximate your function, throwing out things that are relatively small. You'll see more examples of what that looks like as we go on. So I'm going to go ahead and put this on our graph here in green. All right, y equals 3 is a horizontal asymptote. And then that red one was, well, x equals negative 5. All right. I like 3/4 here for this. All right, now let's start sketching here. And this one I think you'll find is really cool. Watch this. All right, let's sketch one over here. This is, let's see, negative 5. Let's just try like negative 6. And when we run negative 6 through this, let's see, we get negative 18 in the top. We get negative 1 in the bottom. So we get 18 out of that. So negative 6, 18. Now it's kind of off my graph here. Okay, way up here. Probably shouldn't even try to sketch it. I try moving over here a little bit. So negative 6, negative 7. Let's try negative 8. I'm just going to get myself a decimal for that. All right, so let's see, we got minus 24 up top. And if we put negative 8 into our function here, we're going to get minus 3 in the bottom. Oh, we get 8 out of that. All right, so negative 8, 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can kind of sketch this. A lot of this graph is just going to be out of our kind of region here, but it's got to be doing this, going to plus infinity, and this thing's got to be, whoops, approaching the asymptote over on the left. All right, let's take a look at this region here. Let's put in 1, 2, let's see, 1, 2, let's just try negative 2. See what we get out of that. So we get, looking at our function, we get negative 2 up top. I'm sorry, negative 6 up top. Divided by 3 in the bottom. Negative 2, negative 2, okay. 1, 2, 1, 2, okay. Let's, how about x equals 0? If we put 0 in, get 0 up top and 5 in the bottom, so 0, we know it goes through 0, 0. That's probably enough to kind of sketch this. It's got to approach the asymptote. A couple more points would have been nice in here, but that's good enough. It's got to approach the asymptote. There we go. Not the best example here, but good enough. So I think what I'll do is just end this video right here. It's at 11 minutes and start another one for the next set of examples. Have a great day.